3.1 Desmos Lab. If you're watching this, you might have been absent, or maybe you just need a quick refresher on what was covered in this lab. I'm Mr. Cortez during this whole video. Let's dive into it. 3.1, getting ready for a pool party. What's happening here? We are introducing features of functions. Our goal is to use the story context to graph and describe key features of functions. I'll tell you right now, some of the functions you could talk about. Some things you could say would be the maximum, which is the highest point. So out of like this graph here, the maximum's this point right here, because it's the highest point. You could also talk about the minimum, where if there was a hill like this that then went back up, this would be your minimum, the lowest point. So you could reference those two things. You could talk about the domain, which we've seen before, saying it might have been all real numbers or natural numbers or negative numbers or integers, all that good stuff. Again, the domain deals with the x values in the function. The range deals with, well, what do you think? What kind of values? Hopefully you're saying y values. So those are four things you can mention when we talk about functions. You could also mention where it's increasing. What do you think that looks like when it's increasing? Hopefully you're saying the line is going up and to the right. If it was linear like that, or if it was exponential, it could look like that, going up and to the right. Whereas if it was decreasing, if it was linear, it would go down and to the right. If it was exponential, it might start off like a straight line, but then just nosedive straight down. You could also talk about the y-intercepts, which occurs on the y-axis. So this point right here, we sometimes call this b, if we're talking about slope-intercept form, or no, that's about it. Yeah. Not to be confused with the x-axis and the x-intercept, where if our x-axis looked like this would be considered our x-intercept, whereas up here in maroon, this was our y-intercept. And these are all characteristics that you should be using and talking about and seeing a little bit more clearly, hopefully after this section, maybe with a little bit of practice, but of course, that's where you come in and take care of that practice and ask questions if you're stuck. Did I mention, I hope you're having a great day. So these types of terms are what you could be talking about in this story context. We see that we have a pool party we're getting ready for. Maybe it's a community pool pre-pandemic. We might have not thought about what it's like to empty this pool, clean it, and then refill it. This is exactly what we're considering for the work in this lesson. A student named Sylvia or Yoshi, I don't know, has a small pool in their yard. They wanted to have a pool party with friends. Parents told them it would be okay if they would empty the pool, clean it, and then refill it. Fun chores, right? We are ordering the activities listed here to indicate the order in which we believe they occurred. Well, there's probably going to be water in the pool, and then we'll have to take the water out to clean it. Because I don't know, can you clean pools with water in it? Unless you have snorkeling gear, but I don't. So we have a few things that would involve getting rid of water. We see there's removing water with a single bucket. We have the option to fill the pool with a hose, drain the water with a hose, clean the empty pool, use 3 buckets and 2 friends to empty the water or remove the water, and also to take a break. There are tons of answers you could come up with, but hopefully you're going with the idea that you're starting with the the pool filled with water, and then you want to have it empty So notice you're going to start here where it's filled. You're then going to want to empty it. You're then going to want to fill it back up. The activities in between, you kind of have to think logically on that. So I'll show that this should be going up and up and up. So rather, this is filled and then it goes empty, and then it is filled back up. So the sequence I'm going to have go here, I'm going to have the drained with the water hose first. I'm then going to have single bucket, I'm then going to have the friends helping. I'm then going to clean it and then fill it back up and then take a break. All right. So on this next slide here, you're just filling in the order you had that go in. So again, I had draining the water first. I had this second, this third. I was then cleaning and then filling and then taking a break. And so on this side, we're writing the story of Sylvia's work on the pool. Be sure to explain the ordering of the 6 activities, starting with a filled up pool and drain as much as we can using the hose. There may be excess water left over that the hose didn't get. Womp womp. Let's say that Sylvia tackles this on her own with 1 bucket. Sylvia continues to get tired and hits up the 2 good friends to help get the remaining water. Luckily, they had their own buckets. This is pretty fun to talk about the story, honestly. You can get pretty creative with it. We're then cleaning the pool since it's empty. We're going to then fill the pool back up. We're taking a break. Hopefully we have our Nintendo Switch light charged and have good Wi-Fi. Cool. Cool story, bro. So that's what I'm going to go with moving forward. Here's, of course, could look different. So what did we have going on first? Well, what's happening here? We're sketching a graph showing the height of the water in the pool over time, including all 6 activities Sylvia did in the order I listed previously. Remember, only 1 activity happened at a time. Think carefully about how each section of your graph will look. Okay, sounds good. So again, we did this first, did this second, 3 buckets third. Cleaned it, filled it, broke it. All right, so drain the water with a hose, same rate as filling the pool. So where do you think this is going to start? We're measuring time in X, the height of the water level in the pool with Y. How much water is going to be in the pool? Is it going to be filled? Is it going to be half filled? What do you think? There's definitely going to be some water in it, you know? So we got to give respect to that. So I'm going to show this starting point here, and I'm going to have this start to go down because if we're lucky, the hose works pretty well and does a pretty good job. So I'm going to say that this is the first activity with the hose draining the water. All right. Remove water with a single bucket. Well, I know that, and this is kind of a tough thing to grasp. We could just have this go down, but hopefully we can agree that like they're going to be small increments taken out at a time. So like there's probably going to be a subtle jump from here to here, because if we start taking buckets, it's as if we take a lot out at once. It's not just slowly draining it, you know? So We'll have this go on for a few moments, and I'll call this part 2. We have the extra buckets, so I'm going to actually have a larger increase of space between these. So I'll say that these 3 dashes represent activity 3. We're then cleaning the empty pool. Well, what does that look like? Can we clean it when there's water in it or when it's empty or what? Hopefully you're saying that we just clean it when it's empty. So there's going to be no water in there and we have to give respect to that. So it's really just going to be a flat line. And what's cool is that we can actually jump ahead and call this a constant area. So this is constant because it's flat. And you could also say that this is where it's decreasing. And you could also say that this is our y-intercept. Does that make sense? We can already say a lot just based off of that. So what's going on next? We are filling this back up the whole way using the same steepness as 1. So I'll do my best to make sure that's shown pretty steep. And this was the 5th increment. And then taking a break. Well, is any more water going to be added if we're done filling and we take a break? What do you think? Hopefully you're saying no. It's just going to flatline. So we have another increment here for 6 where it's constant. So at 6, this is constant. At 5, this is where it's increasing. Sorry, I'm getting lazy and writing ink. Do we have any X-intercepts being used? We sure do. All of these down here would be considered our X-intercepts. We have our y-intercept we already talked about. What else could we talk about? We did intercepts. We said where it's increasing, decreasing, constant. I guess you could say that in the 2 and 3 area, it's also decreasing here. It's a mix of decreasing and constant. Like I know it's jumping, but yeah, the lines are kind of flat. So you have a few ways you can describe that. For the domain, I'm going to say that this is probably, I don't know, 0 minutes. And maybe way out here, this is 90 minutes. Of course, you could change it up, but I'm going to say in this case, it's from 0 to 90. And for the range, this deals with y. And I'm going to say that this down here is when there's, I don't know, what's the height of the pool? Most pool, well, let's say that this pool is like maxed out at 5 feet. So I'm going to say that my range is from 0 to 5 feet. And again, you could use different numbers if you want. We have a minimum down here so we could say that there's a minimum where at y equals 0. It's pretty cool to mention because it's the lowest point. And then where do we have maximums? Where are they at? We have definitely a maximum here, but also here. Because this is where the pool is filled up the most, where it's filled up all the way 5 feet or so. Is there anything else we could talk about? I think we did a pretty solid job. Some other things you could have altered is the order. You could have had a different steepness for some of these too with the buckets. You could have had a straight line kind of going there with the buckets. We've talked increasing, decreasing, domain, rate, intercepts. The rate of change, hopefully, again, we saw that the steepness on this line is the steepness for this line, even though one's going down, one's going up. Like this might be a slope of -5, and this may be a slope of +5, but the same kind of steepness, you know? That's about it. Yeah, hopefully we can also agree that at any given moment in time, the water level is at one specific height. Like we wouldn't want to say that at the very beginning, we have the height of the water at 5 feet and also 2.5 feet. It does make sense. So that would actually make this a function, which is pretty cool because time keeps moving and the height of the water keeps changing. I hope that this video was helpful. If you have any questions, holler, let me know. Thanks for watching.